Astronomy. Magnetar. In 1977, in 1979, scientists detected a sudden spike in the gamma rays that has never been before experimented. Over the next several years, scientists detected that an unidentified celestial body sent out powerful bursts intermittently. Scientists struggled to determine what was causing this larger burst. The series, the series, series that whatever it was, it had to have a super strong magnetic field in order to release amounts of energy that it did. By the time another burst was detected in 1998, scientists had come up with an explanation to explain this strange anomaly. The source of this larger burst was termed a magnetar. A magnetar is defined as a type of neutron star that possesses the strongest magnetic field of anything in space. A magnet. The refrigerated magnet measures 100 Gauss, while the Earth's magnetic field is 5 Gauss. A magnetar measures as amazing 50 times Gauss, make it at least 100 trillion times 100 trillion to 10000 as powerful as magnetic fields. Occasionally, the magnetar will experience thunder bursts and whirlwind flashes of gamma rays into space. Not much is known about the mechanics that cause these magnetar bursts. Expand that result from the instability of the star's powerful magnetic field. One series spectacles that the unstable magnetic field causes star crust to fall and crack, further disputing the star's magnetic field and generating massive waves that release large amounts of gamma rays into space. Although the actual series was proposed in 1992, magnetars has not yet been categorized as a recognized major type of star. A magnetar is, however, classified as a subtype of neutron star. A neutron star is formed when the mass star dies by collapsing into the supernova and a stellar explosion. The mass of neutron star is greater than the mass of the Sun, but is contained in a star with a diameter of only 10 to 15 miles, about the size of the Manhattan Island in New York. The same star is composed mostly of neutrons and has very strong magnetic field. A magnetar has a magnetic field 1,000 times stronger than any other type of neutron star. This gives an extraordinary amount of power for such a tiny star. Normal magnetars can generate the amount of energy in 1 second that it took sun a year to produce. However, the magnetar bursts in 1979 and 1998 were abnormal even for magnetars because they were approximately approximately up approximately approximately 1,000 times brighter than a normal magnetar. In fact, during the brief period of this outburst, the magnetar was brighter than the supernovas. The energy of the radiatus from the supernova in the short period between when it exploded and when it faded is equal to the amount of energy the sun radiated over 10 billion years. Yet the two abnormally strong magnetars of 1979 and 1998 surpassed its supernova in both brightness and energy. Magnetars are also unique because they produce a multi-burst of burst, burst, bursts light of light and that lasts only a second, much like a pulsar. A pulsar is a political flash of light from a star that is sending a constant beam of energy or light away from itself. Due to the pulsar rotation, it appears to be blinking on and off as it light sweeps over Earth. Scientists predict that there are likely millions of magnetars in the galaxy, but only 5 magnetars has been discovered since the first one was observed in 1979. A recent magnetar was observed in late December 2004. This burst is considered the brightest burst ever. It was only 25 seconds long, but it was powerful enough to overwhelm energy detectors on the many satellites in space, so that no energy measurement can be taken. It also interfered with radio communications on Earth. The magnetars was an estimated 30 to 50,000 light years from Earth. Scientists said that the magnetic force is so strong on the magnetar that it could web a critical claim, or make it infinite, in infinite from distance of 100,000 miles, or about half a distance to the moon. Although scientists have only been able to detect a few young magnetars, but they expect to detect many more in the future. Much about magnetar remains a mystery, and there are challenges for scientists to study since they appear once every few years and are observable only for seconds. Scientists hope to determine more about what causes the instability, willing a magnetars are magnetic field so that they can be better understand these powerful bursts. Gamma ray, a type of radiation with short wavelengths, they can pass through the solid objects. Celestial, in or related to the sky, heaven, or space. Crust, cruise. The thick over surface plane